problem 4.8.1 from James Stewart's calculus book. And in this section, we're learning about antiderivatives. An antiderivative is a function such that when you take the derivative of that function, you end up with the other function. So if this is the first derivative, the antiderivative, that would be the function that you differentiate in order to get this function. So this is a polynomial function. So one of the first skills you have to learn before you tackle more complex functions like exponential functions or logarithmic functions or trig functions is you have to at least know how to handle a polynomial. So how do we find the antiderivative of x to the n? Well, to differentiate, we bring the exponent down, decrease the exponent by 1. So therefore, to find the antiderivative, we would add 1 to the function, and then we would divide that by n plus 1. Now, if that doesn't make sense to you, let's differentiate that, because after we differentiate it, we should end up with our original function, which, if you recall, actually I'm going to write it aside so that you can remember. Original function is x to the n, and we claim that x to the n plus 1 is equal to, is the antiderivative. Okay, so x to the n plus 1 is the antiderivative. And to prove that, I will simply take the derivative and make sure we end up with that proof. So we have x to the n plus 1. If this is truly an antiderivative of x to the n, taking the derivative of that should give me x to the n. So in blue, I'm going to go dx of x to the n plus 1. Well, that is just bring down the exponent times x to the n plus 1 minus 1, and we have here, these cancel. This becomes x to the n plus 1 minus 1 is x to the n. So that's our proof. So now that you believe that, we can go ahead and apply this rule. The rule that the derivative of x to the n plus 1, x to the n is x to the n plus 1 over x to the n. Okay, the first one. So first we have x to, you can treat this as using the rule by just saying this is x, really x to the 0 plus 1 over 0 plus 1, right? But this is just 1 and this is just x. So whenever you see a number without an x on it, it's just really the antiderivative of that is going to be whatever the coefficient is times x, because if you take the derivative of 1/2 x, you get 1/2. Next term, 3/4 x to the n plus 1, so 2 plus 1, all over 2 plus 1, minus 4x, oops, 4/5 x to the 3 plus 1 over 3 plus 1. This gives us plus some constant. So that gives us 1/2 x plus 3x cubed over 4 times 3, 12. So minus 4x to the 4th. 5 times 4 is 20, plus some constant. That gives us 1/2 x plus x cubed over 4 minus x to the 4th over 5 plus c. which is the answer to number 1. Okay, let me make sure I didn't make any mistakes. Okay, that's good. All right, hope you guys enjoyed the video. Make sure you subscribe and send me questions if you have any, a problem that you can't solve. I'll see if I can shed give you some tips and pointers on how to solve the problem and solve it myself. All right, thank you.